Today we're going to talk about something called direct variation. And we've used direct variation before, we just haven't called it that. Direct variation is an equation in the form y equals ax. Well, this may look for a little bit familiar because we did y equals mx plus b at one point, where m was your slope and b was your y-intercept. Now, you see the difference here is that we don't have a b value. There's no y-intercept, but you still have a slope. So when we talk about y equals ax, your a value or your slope can't be 0, because then it would just be y equals 0. So we're going to look at these a lot of the same ways that we looked at linear functions, but we just don't have a y-intercept. So it is said that y varies directly with x. This is what you would see in story problems. And the non-zero constant, that a term, is called the constant of variation. But if we compare that to y equals mx plus b, we see that your a value is just your slope. So when I ask you for that constant of variation, it's just a fancy way to ask for what is a slope here. So you can go about it the same way. It says a recipe for 24 corn muffins calls for 3 cups of flour. The number of muffins m varies directly with the amount of flour f you use. So the number of muffins m varies directly with the amount of flour you use, F. Oops. So M is equal to A times F. And again, A is your slope. So 24 corn muffins, that's M. 3 cups of flour, that's F. So we can say that 24 is equal to a times 3, and we divide both sides by 3, a is equal to 8. Now, you might see a shortcut that we could have done at the beginning. We know we're going to divide both sides by f, that 3. You could have just said that a is equal to m over f, and that would have gotten us our a value. So now we can write our equation as m equals 8f. And then estimate how many cups of flour are needed to make 72 muffins. 72 muffins, that's our m. So it's going to be 72 equals 8 times f. And when we divide both sides by 8, f is equal to 9 cups of flour. So this one I asked you to plug something in for y. You could think about it as, the number of muffins, and then work your way backwards. Now, we alluded to this earlier, y equals ax. In that last problem, I said, we could have done a shortcut. To find that a value, we could have taken y over x, or in that case, m over f, the two variables divided by each other. And if we're given a table like we are below, we should be able to take all of the y values and divide them by the x values, and that should give us the same constant. So if we look here, we should be able to do 24 divided by 1 equals 24. And then we should be able to do 12 divided by 2. That gets us 6. These two numbers are not the same. So this is not direct variation. It would have to be the same for each one of them. So let's say that I did these first two here and I got the same number. I would have to keep checking to see if it's the same value all the way across. So So what I want you to do with these tables is get out your calculator and do y divided by x for all of these and see if you get the same value each time. So go ahead, pause the video, try it. Once you're done, unpause it, and we can talk about it. All right, so you can see my answers here. The first one was not a direct variation because we did not get the same constant each time. But the other two were direct variations. And you can see that after I got that constant, I was able to then write the equations here. So direct variation is pretty simple. It's just you got to make sure to read the directions carefully. So thanks for watching. Make sure to like and subscribe. Today we're going to be talking about inverse variation. Inverse variation is written as y equals a over x, where a is that constant of variation that we talked about with direct variation. We also have that with inverse variation. Now, something to note with inverse variation is that if we want to find that constant, all we have to do is multiply the x and y values. Whereas with direct variation, to find that constant, we had to divide them. So this can get a little bit confusing because inverse variation, the general equation is y equals a over x. But to find the constant of variation, you multiply x and y. Whereas direct variation, that equation was y equals a times x, and to find the constant, you divided x and y. And then in word problems, we see the word inversely. That's how you will know to use this formula. So example number 1 is asking us to determine whether these are direct variation, inverse variation, or neither. So we need to get y by itself. So if we add 3x to both sides, we get y equals 3x. So that is a is 3. So that means this is direct variation. Letter B, we need to get y by itself, so we multiply both sides by y. You get y times x equals 3. Then divide both sides by x, you get y equals 3 over x. So we have a number divided by x. So that means this is inverse variation. Now, letter C, what we have here, once we get y by itself, is y equals negative x plus 5. Well, we have that plus 5 sitting out there, so this is neither. Letter D is asking us from a table to figure it out. So what you have to do is divide your y over x to see if they get the same value for all of them. And if you do, that means that is direct variation from the other day. Or if you're going to test for inverse variation, you would multiply x and y. So 21 over 4 is 5.25. And 14 over 6, well, 14 over 6, we want to see if that is equal to, we want to see if that is equal to 5.25, but it's equal to 2.33. So it's not direct variation. So now let's check for inverse. 40 times 21 is 84. 6 times 14 is 84. 8 times 10.5 is 84. 8.4 times 10 is 84. And 12 times 7 is 84. So since all of these are equal to 84, or the same number, this is inverse variation. If just even one of those was not the same, then we could not say that this was inverse variation. So down here, I want you to try all of these to see if it's direct, inverse, or neither. So pause the video, try them all, and once you're done, unpause it to see what you get. All right, here are the answers. So like I said, you needed to get y by itself in all of them.
So for letter E, you get y by itself. I get y equals negative 2x. So that means that it's a direct variation. Letter F, it was already in y equals a over x, so that's inverse variation. Now letter G, once I started manipulating that, I got y equals x over 5. Remember, inverse variation is a over x. So this is not an inverse variation one. So what I did is rewrite dividing by 5 as multiplying by 1/5. So now it's more obvious that this is direct variation because your a value is 1/5. Then for letter H, I multiplied all the x's and y's and got the same number, which was 9, which means that this was an inverse variation one. So down here, I want to do this problem. The variables x and y vary inversely, and y is 15 when x is 3. Write an equation that relates x and y, then find y when x is equal to negative 10. Since we know this varies inversely, to get our a value, we can do 15, a equals 15 times 1/3, 15 over 3, which is 5. So now our equation is going to be y equals 5 over x, and it's asking us now to plug in negative 10. So y equals 5 over negative 10, which is equal to negative 1/2. All right, so down here I wrote out the differences between direct and inverse variation, what the equations look like, how to get the constant a variation from a table or from a word problem, and then what words to look for in a word problem. So take a minute to copy this down. Hopefully this was a great introduction to inverse variations and to see the difference between inverse and direct variation. So thanks for watching. Make sure to like the video and subscribe.